Welcome to Brain Vision.
In this problem, we have a neodymium-glass laser that's emitting short pulses of high-intensity electromagnetic waves. And those electromagnetic waves are passing through a surface perpendicular to the laser. So some surface here. That's perpendicular to the laser. And the area of that surface through which it's passing, so this small little area through which the laser passes, is equal to 1.6 times 10 to the minus 5 meters. So pretty small area there. And what we want to find is the average power of each of those pulses. So P average for each one of these pulses. Well, the equation that we know for the average power is that average power is equal to the average intensity times the area. So we know what this area is, that was given to us. We need to solve for the average intensity. You might recall that average intensity is equal to C epsilon naught times the average of the electric field, the root mean square, squared. Well, we know what ERMS is. That was given to us in the problem as well. ERMS is equal to 2.0 times 10 to the 9 newtons per coulomb. And then C and epsilon naught are also known. Those are just constants. C, speed of light, 2.9979 times 10 to the 8 meters per second. And epsilon naught, the vacuum permittivity, 8.85 times 10 to the minus 12. And that's in units of coulomb squared per Newton meter squared. Now that we have all of that, we can plug it in and solve for the average intensity. So I'm going to plug all that into my calculator, C times epsilon naught times the ERMS squared. And we'll get that the average intensity is equal to about 1.0613 times 10 to the 16th. And the units there are watts per meter squared. Now that we found that, we can go ahead and plug it back into our equation here for the average power. P is equal to S times A. And we have 1.0613 times 10 to the 16 watts per meter squared, multiplied by the area, 1.6 times 10 to the minus 5 meters. Plugging all that in should get about 1.7 times 10 to the 11 watts. Sorry, area is measured in meters squared. So that's how we have our units of meters squared cancel out, and the power ends up being just 1.7 times 10 to the 11 watts.